Good afternoon. I am Dr. Parthasarathi Das, Associate Professor, Department of Electrical Engineering, Haldia Institute of Technology. Today I will discuss regarding the activity of or application of microprocessor. So, introduction to microprocessor. Microprocessor is the main part of a computer. So, nowadays we all use computer and it is the integral part of our life. It becomes an integral part of our life. So actually the processor what we use in our computer is microprocessor. So microprocessor is the main part of that computer, of a computer. So depending upon the architecture, depending upon the quality, depending upon the manufacturer, the quality of a computer depends. The quality of a computer totally depends on the processor which we use in that computer, and that processor is basically a microprocessor. A computer may be called a microcomputer if it contains only one microprocessor. So today we sometimes called a microcomputer. So microcomputer is nothing but a computer where there is only one processor is there. So as I told that microprocessor is the vital part of a computer. The cost of a computer, the efficiency of a computer, all depends on the processor which we use. The other parts of the system which are connected to the processor includes memory, peripherals, etc. So memory is a storage device where we can store data, where we can store different instructions. Peripherals means the external devices which we connect. Peripherals may be a keyboard, peripherals may be a mouse, so like this. The peripherals includes input-output devices like mouse, keyboard, display devices, etc. The CPU, Central Processing Unit, of a system includes ALU. ALU, full form of ALU is Arithmetic Logic Unit, Register Array and Control Unit. The portion where different arithmetic logical operations are performed called arithmetic logic unit. Now, what are the arithmetic operations we perform? Arithmetic operations include addition, subtraction, like this, and logical operations include AND logic, OR logic, like this. So these are the logical operations. So that portion of the CPU where we perform these arithmetic operations like addition, subtraction, logical operations like AND logic, OR logic, called arithmetic logic unit. The register stores data for further manipulation. So the data which we use for different purposes when we need some manipulation or when we need some particular data among different data, then that data that stored in register array. The control unit sends necessary signals for communication between processor and peripherals. This is the diagram So microprocessor actually can communicate with one at either it will communicate with its input devices, output devices together called peripherals, or the microprocessor may communicate with memory unit. Here you see this is a very vital structure. This is this portion actually the CPU portion, where one part is ALU, one part is control unit, one part is register array. So the microprocessor there they communicate between each other with this. This is the input portion, this is the output portion, this is the arrow, unidirectional arrow, and this is bidirectional. That means microprocessor can communicate with memory in a bidirectional way. That is, if we want to store something or write something, that means this is from CPU to memory unit. Now, suppose there is a previously stored data. There is some previously stored data in the memory unit. I want to manipulate or I want to work with those data. So what I will do? Then I will take data from memory unit. That means communication in both ways. When we need to write something, we can write it in the memory. When we want to get some data, that is, want to read some data from memory, we can read. So it is a bi-directional process. Now, as I told that ALU, this portion, arithmetic logic unit, this is control unit, and this is register array. Now, what is the function of control unit? As I told that microprocessor can communicate with one, either it will communicate with its peripheral or it will communicate with its memory. Now, microprocessor can communicate with one at a particular instant. So this control unit decides that the microprocessor will communicate with memory or input device or output device. So that control unit sends a signal to that microprocessor that the microprocessor now should communicate with output device, microprocessor now should communicate with input device, or microprocessor now communicate with its memory device. Now, this is a very basic pin diagram of a microprocessor base system or a microprocessor. A very basic pin diagram of a microprocessor 8085. 8085 it is a 8-bit microprocessor. Now, what is 8-bit? 8-bit microprocessor means the register of that microprocessor can communicate or can store, the register of that microprocessor can store 8-bit or can process 8-bit data at a time. The register of that microprocessor will store 8-bit data, can store 8-bit data, and the microprocessor can process 8-bit data at a particular time. That means if the bit of that microprocessor is more, suppose a 16-bit microprocessor is more faster than 8-bit microprocessor. A 32-bit processor is more faster than the 16-bit processor. So that is the significance of that bit. That means the register of that microprocessor, they can store 8-bit data, and at a particular instant The microprocessor can process 8 bit of data at a particular instant. At a particular time, it can process 8 bit of data. 8085, it is a very basic microprocessor. Now you can see this is a 40 pin IC. Microprocessor is actually IC 8085. It is a 40 pin IC where each pin has its own role. Now I will discuss here some important pins, the function of some important pins. First I will discuss from pin number 12 to pin number 19. Pin number 12 to pin number 19. You see in pin number 12 to pin number 19 it is written AD0 to AD7. A for address and D for data. So what is address and what is data? Suppose in a town there are 100 houses and we number the house from 00 to 99 in decimal number system. In decimal number system, 100 house can be numbered from starting from 00 to 99. And each house have 8 rooms in it. Now if I decide that if one room is occupied by some entity, it is 1. If it is empty, it is 0. Now suppose I ask someone that you go to house number 45 and tell me that how many rooms are vacant and how many rooms are filled. So that is data. That means if I want to know in a particular house how many rooms in that house, all the houses are identical. All the houses have 8 rooms. And suppose I ask you to, as I told, go to room number 45, and someone sees that in a particular house the rooms are numbered from 00 to 07. So if the data is 01, the rest of are 0. That means I can understand that in that house 0th number room is vacant, 1 number room have an entity. So that is why it is 1. 2, if 2 is 0, it is vacant, 3 is 0, it is vacant. So these are data. And what is 45? 45 is the address of that house. Similarly, in a microprocessor based system, there are different registers, and here in 8085, the registers are of 8 bit, and each register have a unique address. 8085 microprocessor, it is a 8 bit microprocessor, but its address bit is 16. You see, pin number 12 to pin number 19 and pin number 21 to 28. One thing is common, that is A. Pin number 12 to pin number 19, it is AD0 to AD7. Pin number 21 to 28, it is A8 to A15. So A is common. A stands for address, D stands for data. Pin number 12 to pin number 19, these pins we use for both the purposes. That means for data or address. So these are called multiplexed address oblique data bus. Multiplexed means at a different means different times it will function differently. So pin number 12 to pin number 19, if it is used as address bus, so it becomes A0 to A7, and pin number 21 to 28, these are always used as address bus. So only pin number 12 to pin number 19, these are common for address as well as data, but pin number 21 to 28, these are used only for address purpose or means address bus. These are called low order address bus and these are called high order address bus. Now, how the microprocessor will understand that these lines are used as address bus or data bus? Look at pin number 30, ALE. It is written ALE stands for address latch enable. When this is a digital system, either 0 or 1. If pin number 30 is 0, that means microprocessor will understand that pin number 12 to pin number 19, they are data. And if ALE is 1, microprocessor will understand pin number 12 to pin number 19, they are address, low order address. Now for the first case, if pin number 30 is 0, pin number 12 to pin number 19, 8 pins, they become D0 to D7. So total 8. So that is why 8085, it is a 8-bit microprocessor. Now when it is 1, it becomes A0 to A7, low order address bus, A8 to A15, high order address bus. So pin number 30, it is a very vital pin. This pin will decide that what will be the nature of pin number 12 to pin number 19. Other important pins are IOM bar. This is one important pin. Pin number 34, pin number 31 WR bar, pin number 32 RD bar. Bar means they are active low. When pin number 31, it is low, microprocessor will understand that it is a write operation. Similarly, when pin number 32 goes low, microprocessor will understand it is a read operation. Pin number 34, for pin number 34, if it is high, that means 1, microprocessor will understand it is a IO operation, means input output. And if pin number 34 is low, microprocessor will understand it is a memory operation. So suppose pin number 31 is low and pin number 34 is low. That means it is a pin number 31 low means write operation. Pin number 34 low means memory operation. That means if pin number 34, 31 both are low, that means it is a memory write operation. If pin number 32 is 1 and pin number 31 is 0, pin number 34 is 1. That means it is a pin number 31 0. We will look, and pin number 34 is 1. That means it is a IO write operation. These are pin number 7, 8, 9, 10, 6, 7, 8, and 9. And these pins actually we use for interrupt purposes. So this is INTR means interrupt request. INTA bar means when this pin goes low, this is that means microprocessor will understand that it is the interrupt acknowledge operation. There will be the interrupt which is the highest priority interrupt. SOD, SID, they mainly need for communication purposes. X1, X2, they are for crystal oscillator purposes. And these two, so this is actually supply, and this is we use for ground. So this is the quite introductory description of 8085, a very basic microprocessor. So microprocessor is a remember it is a digital device, digital IC. This is a it can only understand 0 and 1, and the function of computer, if we use this 8085 in the computer, the function of that computer will fully depend on the function of this microprocessor or on the function of this processor. That means the total computer system we control with the help of this type of IC. So, thank you for that lecture.